Antarctica, and Erin Wansborough from SODA. The judges, ladies and gentlemen. So we've got the problem up there. There is some judging criteria as well, I believe. There you go. That's the criteria that they are judging against. The 5 finalists have provided an innovative solution that covers a range of things, from machine learning to augmented reality, spectroimaging, AR rocketry, aerial automation. It's all sorts of amazing stuff. So without any further ado, we're now going to hear from Sakti Rangathan and Sanchos Seshadri from JIX Limited and Orbica Limited with their Pokemon Go style augmented reality system that uses holographs and geospatial data sets to visualize the physical environment and navigate the terrain of Antarctica. The time is going to be monitored, and they're very, very strict about time. Gentlemen, the floor is yours. I should say that we're representing the 5 different regions. These are the guys from Christchurch, Canterbury, Marlborough and West Coast.
Good afternoon. Yeah, could you hear us? Okay, sweet. Good afternoon, guys. Thank you for giving us an opportunity to present at this inaugural Space Challenge. So obviously we are jointly proposing this idea, and it's between JIX and Orbica. Let me click on. Sweet. Okay. So obviously the challenge was, we know that Antarctica is a pretty harsh environment. We've seen from a plethora of talks this morning. It's really hard to navigate the landscape. There are no physical features out there. And so one of the challenges that we're trying to solve is how do we traverse, or how do we navigate this particular landscape. So what we've come up with is a geospatial and augmented reality navigation system. And what it is a collaborative planning platform where people can get together around a table and plan their particular activity, plan their event, plan their route, and then seamlessly port that into a vehicle navigation system. So how are we doing that? First, we are acquiring the StereoStar datasets that's already available now to generate a high-resolution digital elevation model, and then we're generating slopes from it. So once we generate slopes from those VEMs, we know that which areas are steep, which areas are not as steep, and then using those slopes, we can generate a least cost path to generate a route that misses the crevasses and goes around them. So here's a quick demo on how that works. So what you're seeing here is, this is the Antarctic landscape, that's the Ross Island up there, and as we're zooming in, we just worked a small demo for this particular event, and that's the area we're working on, the small square box. And as you can see, those are lat long, so those are actual locations on the Earth. And now what we're going to do is, the middle part there is the crevasse field. As you click a few sections, you're going to start seeing a route that's being generated using those slopes, right? And right now we are only using slopes, but again, there's nothing stopping this from complementing with other data sets such as land use, ice sheet, snow depth, anything that you can think of can be complemented in order to create this route and optimize these routes to navigate around these crevasses. So this solution is accessible and offline because all of the data and all of the algorithms can be placed locally in a computer system. The algorithms are open-ended, which means that we can easily complement and add data as we need. It's both geospatial and augmented reality are proven technologies, and they're all working in one seamless ecosystem. I'm going to hand it off to Shakti to talk about the AR side of things.
So what we are seeing here is a collaborative table. It's an advanced sandbox with augmented reality enabled system. So we know we can't make mistake right in the field. So it's better to plan and get prepared. So in the planning phase, so this is quite used in military training and also in city planning and infrastructure. But what we are going to take is a sandbox and apply augmented reality, and then get the visual, get everyone around us and plan for it. So here is a small prototype that we put together here in our office. So we are detecting the surface, and basically we are going to place the Antarctic terrain right on the table. So So the Antarctic terrain is placed here, and then same data set which Santosh used to explain in the terrain is imported here with the same crevasses detail, and there will be a point A and point B, and then the same navigation system works in augmented reality. So imagine, what if, like, it's not just like going out there and struggling, like we have to plan and plan inside the safe environment and make sure everybody knows. And the best feature is you can apply any other extra features, extra elements like wind, weather, and there's a lot of changes which can happen, which can be simulated within this environment, which lets us better planning and better safety. So that's the demo. So after this data set, what we are trying to do is take the same information and into a computing system inside the vehicle, basically, and then place it not just a head-mounted display or an advanced augmented reality. Even a simple turn-by-turn voice command inside the vehicle could be used to safely maneuver around the Antarctica. So there are other examples which already be implemented, like visualizing the underground pipelines, and there's some images from the current vehicle navigation system. So this is what we visualize. So I'm sitting there. Sorry, I can't sit there. So obviously, so you can visualize from it, like it's an X-ray image saying like what turn you have to, what is the point that you have to take left or right, without any interruption. So the same data which you planned on the system comes out here and gives you the better visual.
So yeah, so in conclusion, so what we're doing is we're taking already existing data, generating routes with pre-existing technologies, and then creating a augmented navigation system. Finally, this wouldn't have been possible without the help of the team who's sitting right here. It's Neil, Afi, and Suvarna right there. And so, thank you. That's the idea. Thank you.
Questions from judges?
Yep. Yeah.
What market validation have you done? What feedback have you had from the field so far about this concept?
So both geospatial and AR technologies are currently being used in almost every industry. So routing algorithms are already there, everybody's using it. We're just implementing it in an Antarctic environment where the data doesn't exist. We're using existing data to do that. So the algorithms are proven, the technologies are proven, we just need a platform to launch it in order to be able to.
So that's the reason why we could build a prototype within the stipulated time, is like we could validate and we can build it and test it.
So you've built a prototype, and have you tested that concept with any scientists in the field?
So that's the next step. What we want to do is we want to work with scientists to figure out what other data sets we can use to complement that. Because obviously we are not Antarctic scientists, right? So we are geospatial technologists and augmented reality specialists. So what we want to offer is working with scientists to complement this with additional data sets that they can acquire in the field. Yeah.
You said you were going to integrate the different data sets. Are you going to integrate the GPR that's out front?
Yes, that can be integrated as well. Yep, I can see. If the data is available, it can be easily integrated because it's all geospatial data. And that's the beauty of geospatial data, is everything is location oriented. So if you're collecting the data, and it can be easily overlaid on top of your terrain, and we can use that to further improve our routing techniques.
That's a challenge that we had, specifically as a two startup working together. Like I had no idea about geospatial, and he had no idea about how this could be implemented. So it's a learning experience for us. Thanks for this opportunity here.
Yeah, hi, can you further elaborate on your use of space technology?
So currently, all of the data sets that we're using there are real life data sets that are collected using satellites, right? So DEMs, aperture radar, SAR data, all of these are used, and imagery is also collected by space technology. So all we're doing is we're using existing space technologies to implement this solution. And as long as there's more and more data sets are available, it's all data driven. So as the community here can generate more data, we can easily integrate that as part of the system and deploy.
And mostly augmented reality is more fancy and gimmick, but here we just used what is available in geospatial and recreated it. So it's not like trying to create a cinematic experience rather than a scientific experience.
Thank you.
Well done, thank you very much.